I gotta go through all my...
It's when I would put it like, oh yeah, thanks for this audio, smiley face, and I was like, okay, he's actually not proud of the work.
No, yeah, and I think you said like you thought at first that it was like that,
yeah.
And then after a while you're like, oh, this is just how he messages.
He's sicko.
Yeah, I know.
He
Yeah.
never changes ways.
Alright, get out of here before you guys make me to work. See you guys, thank you guys.
See you later. Okay. We have Tyler in the house. No one else. Oh man, lecture 2 or 3 was just like this, huh? Yeah. That was hard. That was a hard one.
You're doing good.
Yeah, we're doing alright. We're doing alright. I'm gonna take some attendance right now. I'm gonna wait like a minute or two to see if people trickle in, but if not, we'll just get started. How's the quarter been for you, Tyler?
Pretty good.
Yeah.
Yeah.
Not too intense?
Just right.
Just right. Okay,
Yeah.
cool. Yeah. Yesterday, everyone was here, I think. Right, Audrey?
Mm-hmm.
Yeah. And the day before, I think also everybody was here. And today, only Tyler's here so far. We'll see how it goes.
Anshu released the solutions for lab because he wants us to help the students for a wolf pack.
Okay.
So I'm also just going to make an announcement that way.
Sounds good. Okay. Just wait a couple more minutes. And then I'm going to pre-make some dog pictures. Welcome. All right, it is now 12:33. I think we're going to go ahead and get started soon. All right. I'm going to get started. Hello, everybody. Welcome back to another wonderful iteration of CSE 8A, Intro to Programming in Python. Today, we're going to be covering some image transformations in a function. Okay, so recently what we've been doing is we take in an image, right? We take in an image. Then what we can do is edit it, right? Edit it like doing a filter. What did we do yesterday? What kind of filters did we make yesterday? We did a filter. We made everything like one color. What else did we do?
Like a corner.
Oh, we did the corners, like the quadrants, right? We did like certain quadrants of an image, right? So we've done those things. But today we're going to be able to do that now using functions, so that we can edit it specifically depending on some inputs that we get in a function, right? So, a couple of announcements. PA5 is due on Friday. We're going to be going over some super relevant problems in lab and discussion this week. So again, please head out over to lab and discussion this week. And then also the one-on-one tutoring sign up. It's still up and it's still live. So if anyone still wants to sign up for some one-on-one tutoring, please go ahead and do so. Yeah, so please go ahead and sign up for that. All right, so we've done image transformations. Now what we're going to do is do an image transformation, right? We're going to do an image transformation, but now what we're going to do is we're going to do it using a function, okay? And we're going to use it using a function to create this checkered pattern, where you first have some image, right? In this case, it's a cat. And then within that image, like inside, in like a random spot, well, not random, in a predefined spot, we're going to give it a checkered pattern, okay? A checkered pattern. So somewhere within this space is where we're going to make that checkered pattern. Does that make sense? What we want to do? Yes, no, yes, no? Cool. All right. Let's see. All right, so we talked about filters already. Hello, welcome, Noah. All right, so we're going to go ahead and get started doing some live coding. Feel free to also write this down in your lecture notes, right? So this lesson can be found in lecture. It's in the lessons tab. Go to lecture. I think it's lecture 15 today to see this this thing, and you could like write along as I go. Okay. So we now have an image, right? We have an image, but now what we want to do is make a checkered pattern inside. Okay, make a checkered pattern inside. Let's start by doing the checkered pattern inside, and then we're going to put that all into a function, okay, so that we can see how we can work with this in a function. So we have an image. Does everyone remember how to display that image? What can we use in CSE 8A image?
Save image. Save
image, right? Save image. And then you have to put in the image that you want to save, as well as some file name. In this case, I'm going to put like sholonu.jpg. Okay. Cool. So when we run it, again, right now we're just loading an image and saving it. We're not doing anything to it. But what we're going to want to do now is put some sort of checkered pattern inside. Okay? Some sort of checkered pattern inside. Now, where should I start off this checkered pattern, right? So like here in this like cat image, we see the checkered pattern is like somewhere here. Like in the top left, kind of like in the middle. We don't really know the exact point where we want to start this checkered pattern. So what we want to do is make one up for us. Okay, so we're going to have some sort of starting point. So we can say start point. And we're going to say start point row. So like which row do we want to start on? We say that we have like around 800 rows. Where do we want to start on? We can give it any number. What number do you want? Caesar. Wait, what?
100.
100. Great number. Okay, great number, 100. So we're going to start off on row 100. We want to start point of column. We want to start off at a specific column, right? We have like around 700-ish columns. So we're going to start like 100 rows top to bottom, like around there. What column do we want to have? Any number. 200. 200. Very nice. Okay, 200. Okay. So now what we can do is, let's just see right now, we're going to print out my image at start point row and start point column. Okay? We're just going to see what that looks like. Are we getting some sort of number? Yes, we do. We get 255, 255, 255. What color is that again?
White.
White, right? So at that specific point, at row 100, so like 100 rows down, somewhere like around here, I think, and 200 columns to the right, maybe somewhere here, I don't know where it is. but it's going to have a white column. Okay? Some sort of white column. Or sorry, white pixel. At this point, we have a white pixel. Does that make sense so far? That's just a position. That's all we have. Now, we have our starting point, but what we want to do is also try to find out what's like the area of this checkered pattern. Right? What's the area of that? We can also give it some sort of arbitrary number. How long do we want this? And we're going to make it a square to make it easy on ourselves. How long do we want this checkered pattern to be? How many pixels? Ella, give me a number. Like a rather large number. Maybe like over 100.
170.
170. Great. Let's do that. So what we want is the length of side to be 170. Okay? That's just what we came up with. Okay? So now we know the following. We know the following. We have our image. We want to start off at row 100 and column 200. And then what we want to do is do, actually I'll do it over here so that I can actually write it. Oh, I already have some dog pictures up. What a fun eating. Okay, so we said column like around column 200, like right here, I don't know, row 100, right? That's our starting point, right? That's our starting point. And now, with what Ella gave us 170, what we want to do is the following. We want to go 170 here, so that each side of this square is 170, right? This is also 170. This is 170. 170. Just because it was in here, that means it's hard to say. Every single one of the four sides should be 170. Okay? So, now we know what we want it to look like. Does that make sense so far? So far? Let's not make it checkered just yet. Let's just have a box inside of our image. Have some sort of box. And let's make it all a filter. Some filter. We've used filters before. Okay? So now we have our 3 points. Sorry, we have our point where we want to start, and we have our length. Okay? So, what does this mean? Now we have our image, we have our starting point, and we know how long we want it to be. Okay? How long on each side we want it to be. How can we start to edit those pixels at like that specific area that we decided on? How can we start?
A for loop.
A for loop. Fantastic. For what?
A row.
For row. In
Range.
range. Cool.
100.
100.
Or start point.
Aha. Yes. You want your start point. Start point which one?
Underscore.
Underscore what, sir?
A row.
Row. Okay.
And then for the end point, you want it to be start point row plus length of side plus
Length.
1.
Row side. Plus 1? Do we want that? Maybe. That's a great question. Actually, no, you don't need it. Yeah, it'll be included. Yeah, we don't need the plus 1. But I mean, maybe I don't know. We'll figure it out right now. Okay. All right. So now we have this. Do people understand what we're doing here now? What this for loop is doing? This first one. We're going to have some sort of variable called row, right? Row. And this row number is going to be a variable. This variable of row is going to have the value of some range. What data type do we get when we look at range? A list, yeah. What will row be when it looks into range?
An integer.
An integer, yeah. Row will be an integer. as we go along. So what numbers are we going to be looking at? We have our range function. We have some point, comma, some other point. Okay? What this means is, for our rows, we want to start off at our start point row, right? So right here we're saying, we want to start off at the start point that we're giving it. In this case it's 100. So this is the row that we're going to start off in, right? That's the row we're going to start off in. And then we're saying, for our range, we want our last point to be the value of our start row, in this case 100, plus the length of the side. The length of the side, I'll put length of side. What is it again?
170.
170, right? So now what we're saying is we want to start off here, and we want to read our rows all the way up until we get to the length of the side plus the row number. So we start off at 100. That means at this point right here, this edge corner, what row number will that be?
2.
200. It'll be, so if we start off at row 100, and we want to go through 170 rows, so we're going to add up to 170 rows, what will this point be in terms of the row number? 170 plus 100?
270.
270. Exactly. So this row number right here, and where we want to stop, that is row number 270. Does that make sense so far? Of how we got there? Great. So now we have, for row in range, the start point, and then your start point row plus the length of the side. Great. We're doing that now. What's our next step? So now we're going through the rows. Sorry?
Another for loop.
Another for loop. Okay. For, what do we want to call that one?
Column.
Column. In, what do we want to do now?
Range.
Range. Tyler, what should I put in here?
Start point column, comma, start point column plus side length.
Point column
Or
plus
side.
length of side. Great. So very similarly to what we did for the rows, we're also going to do to the columns. So we're starting off on column 200, right? So this is column number 200 at this point. And we want to go up 170 points to get to here. What column number is this?
370.
370. That's right. So what we want to do is get some sort of area in here, some sort of area in there. And what we want to do is update it with a filter. All right, so now we have our row and we have our column. What should we do now? So now we have our positions. At this point with this nested for loop, what we're going to do is get every single pixel inside of this area. Everything. But just the position. So what should we do next?
Apply the filter.
Apply our filter. How do we do that? Let's make a red filter for now. Actually, okay, so we have to apply a filter. How did we apply filters yesterday? What we did was we had to get some of those original values, right? How can we get the original values of that pixel?
You create like a variable for the pixel
We have a variable for the pixel now, and what do we do?
equals my image, then hard brackets row, hard brackets column.
Awesome. Okay, so now we have the original values in this variable called pixel. And now what we want to do is keep the red and remove everything else. How can we do that? Caesar, how can we do that?
Add another hard brackets and add 0.
0. Is this going to give us the pixel or is this going to give us the
The
red value of the pixel?
The red value of the pixel.
All right, red value of the pixel. So let's just change this to pixel underscore r. Just so we can like make it easy for ourselves to know that this is the pixel at red. Okay? So now we have this this value for a pixel r. What should we do now? We have the original red value.
Multiply or divide depending on whether we want it to increase or decrease.
Increase or decrease? We could do that. We can definitely do that. But what we want to do just for this for this example is we want to keep whatever the red was and go like that, 0, 0. We just want to drop everything else. Okay? So how can we do that? How can we make it so that the image itself, we're going to change the image itself and give it a red filter? How can we do that?
Image, or my image, row and column equal to what's it called? The tuple.
A tuple. Awesome.
Pixel r, and then set the rest to 0.
All right. Let's see what happens now. Let's run it and see what our image looks like now. Run. Oh, are we still printing out? Oh yeah, we still are. We don't need to print this out anymore. Let's look at this. Ta-da! What this is doing is it's keeping the red value and the rest is going to be blacked out. And to be honest, this just has this blue stuff has just very small amounts of red. You can see the red that stays in with that little flower right there. That still has red. Okay. What we can do is, maybe I like the idea of making it just stronger red. So you said to multiply it or divide, right, by a certain number. So let's just multiply this by, what do you want? What number do you want?
1.3.
1.3. And then what we can do is probably make this my image at row column 1. So we can keep the other stuff and just make the red stronger. And then when we run that, oh, we went an overflow error. Python integer 331 out of bounds. What happened here?
The new R value is goes over 255.
It goes over 255. So what we can do is, what was it again? Min? Right, so we can check to see if it's 255 or this value. We'll just get the minimum value between the two. Let's run that. Cool. Man, you can barely see anything. I mean, you can kind of see how that little red got a little bit more red, but not much, unfortunately. Let's change this up so that we can, let me see what's going on here. Okay. Well, let's keep it how we had before, where when we run this, we can very distinctly see we keep red values, we remove other values to make it. But what we can see here now is that we successfully made this checkered pattern. No, sorry, this filter within a specific area. Okay? But what if I want to change where this square is? What if I want to change its position? How can I do that? Like our starting point. How can I change that starting point? Yes?
Change your start point variables.
Changing our start point variables. Awesome. We can definitely do that. But what if I want to keep on changing it over and over and over again? I want to make new images over and over and over again with new start points every single time.
A function.
We can make a function now. Okay? So, I'm going to go ahead and make a function here. And we're going to say my transformation. Right? My transformation. And what we want to do is pass in a couple of things. What's the first thing we want to bring in to change our image? Probably the image itself. Okay? ing. Then, actually, I'm going to call it my image. Then we want to pass in another thing. How do we know where we're going to start? Tyler, I think you mentioned this right now. We have to change like a certain value, right? What values do we want to bring in so we know where we start?
You can copy and paste like the variable names on line 6, 7, and 8.
Start point row, start point call, and then the length of site. Okay? We need all this information so that we know how we're going to make our pattern, our like filter, right? And what we're going to do now is just we're going to move everything inside. So all of this is now inside of the function. Let's run it, see what happens. Oh no, nothing happened. Why is nothing happening?
We never called the function.
We never called the function. We always have to make sure that we call our functions. Plus image. Okay. So let's call our function my transformation, and what we want to put inside there is our image. We want our start point of the row. Give me a number again. What was the number for the row?
100.
100. What was for the column?
200.
And the length of the side?
170.
170. Okay. Let's run that now. Will this work? Before I run it, will this work? I have my functions. I'm passing in my to-do list and 3 integers, where this is the row, this is the column, and this is the length of the side. And I just call the function. Will that change our image and save our image correctly? I'm seeing some nods. Why? Why would that work?
It's like the same piece of code just inside a function.
It's the same piece of code inside of a function. But will my list update inside the function? Shouldn't I like return it or something like that?
I don't think you have to,
Why would I have to?
because it's mutable.
Because it's mutable, right? Lists are mutable. So when we change them inside the function, they will be changed overall, right? So let's run that. Ta-da! That worked. Great. How about we give it other values? Now, give me a random number between 0 and 800.
10.
10. Great number. Audrey, give me the column.
205. Wait, up until what number?
Up until like 701.
701.
Whoa. 701. Okay. Let's make it halfway through.
Oh.
350.
Censorship.
That's censored. We'll do Audra's number right now. We're going to build our way up into that. And now for the length of the side. How long do we want this to be, Chowfei?
150.
150. Great numbers here. Great numbers all around. So now we have a new start row, we have a new start column, and we have a new length of the side. This was our original one with 100, 200, and 170. So now what we should see happen is that our row starts at pixel 10. So will this be lower, higher, or more left to the right? With pixel 10 as a row? Lower or higher? Higher. Up until pixel 10. Then we're going to have column 350. Is this going to be more left or to the right? Ella?
To the right.
More to the right, right? Because our starting column will be more over here, like around 350. And then, will the area of our square be larger or smaller, Tyler?
I think larger
Larger. Why larger?
was, I can't remember the old number, I think the new one's 150.
New one's 150, old one is 170.
Smaller.
Smaller, yeah. So it's going to be just a bit smaller, like only by 20 pixels. Maybe we won't be able to see it 100%, but we'll do our best. Let's run that. Ta-da! We have our new filter. Now it's somewhere else, right? Now it's somewhere else because of our function. And now what we can do is just do it a bunch of times, and we can have new images every time, right? With a different filter in different spots. Does that make sense as to why this is working? Great. Audrey, it's your time to shine. What area of the circle do we want now? The height of the image is 800. The width of the image is 701-ish. And our starting point is going to be 10 for the row and 350 for the column. How long do we want this to be?
We want this to be.
How, like, what's the area of the side? What is the length of each one of our sides of our square? Sorry. Wait, sorry, yeah. We now have a starting row and a starting column. We're not going to change that. But now we are going to change the length of the side. This used to be 170. Shall we give us 150, a little bit smaller?
Yeah.
You're going to give us a new number.
Oh, 200.
200. Okay. 200. Audrey, I'd like for you to think big. So we have 200 here.
701.
We have 200 here. When we run 200, it's a bit bigger. What do you say now?
701.
701. Let's run that. Oh! Something happened. Something happened. Can someone tell me what happened here? We have our starting row at position 10. We have our column at 350. That's our starting point. What happened now? Why am I getting this error? Index out of range.
You tried to get like a pixel that doesn't exist.
I tried to get a pixel that does not exist. So the way that we have it right now is that we have our starting point. We have our starting point with the row and the column. And Audrey here told us that it's now going to be 701 length of side. We know for a fact that the height of this is 800. We know the width of this, I think it's like around 701, around there. I forget, we can check right now. So that means that if we want the area, sorry, the length of the side to be equal to 701, what does that mean? What that means is we're saying we want our rows to go all the way down to 711, right here, 711, which should be fine, given that row 711, this should be okay, because we still are fitting within the rows. But now what's going to happen? 701. 701 pixels to the right from 350 is way out here. Way out there. Do these pixels exist? Yes or no? No, they don't exist. So when we say, give me the position row 10, column 800, that does not exist. That does not exist. Okay? So that means we have to change something. We have our starting point. We have our starting point row in the column. We have the length of our side. How can we fix this so that this doesn't happen? We're not going to get this error. And you know what? Let's make it easy for the user and say, even if they give us a 701, we'll do the filter. But our filter is only going to work up until here. And we're not going to go out here. But everything else, we'll do a filter on. How can we do that?
If statements.
We can do if statements, right? We can do if statements. Where should we have our if statements?
At the beginning.
At the very beginning? Like here?
Yes.
Okay, let's do that. If, what are we checking for?
Start point plus length of side is greater than height of my image.
So with height, what we're checking for is top to bottom. So we should probably also put if start point row. Totally fine. If the start point of the row plus the length of the side is greater than the height of our image, what do we want to do? One of the things that we want to do is make sure that our end point, so we have our starting point of the row, our end point row, what should be the limit of the end point row? The height itself. Okay? The height itself. So end point row should be the height of my image. For the sake of simplicity, I'm going to put end point row is equal to the start point row plus the length of the side. Like I'm going to start off by saying that's my end point row. That's where I'm going to end. But I'm also going to say if the end point row is greater than the height of the image, then we're going to make our end point row now be equal to the height itself. Like we're going to limit it to that height and that's it. Are we done?
No, we also have to do the same thing for the columns.
Same thing for the columns. Ella, what should we put here? We have to do the same thing we just did for the rows, but now for the columns. What should we do?
Endpoint column
Yep.
equals length of side.
Length of side. Right? Should we add anything to this? So we have our endpoint column, we have the length of our side, and we have to add something to that.
Is it height?
The height, not quite. What we want to do is do the start point column. Okay? So we have our start point column right here, right? In this case it's 350. And what we're going to say is the endpoint that we're going to give now is this endpoint, right? Which is right now we know longer than it should be. 701 plus 350 is 1051. Right? This point right here is a column is equal to 1051. Right? So that's what's going to give us when we do that. Endpoint column is equal to the length of the side plus the start point column. What should we do next? We now have our endpoint column.
If statement.
An if statement. If
Endpoint column
endpoint column,
is greater than width of my image.
the width of the image. Right? Now we're looking at the width.
We set endpoint column equal to the width of my image.
Is now equal to the width of my image. Okay, I'm going to make this a little bit spaced out so we can see. Do we see what's happening here now? So here I'm going to say calculate our end point row. And now here we're going to have calculate our end point column. Okay? That's all we're doing right there in those two blocks of code. We're gonna check to see where we're gonna end. Right? Are we done?
No.
Wow, why are we not done?
We need to readjust the range.
We need to readjust our ranges. Right now, our range is still start point row, and then start point row plus length of side. And then same thing for the column. So, instead of start point row plus length of side, Tyler, what should this be?
Your endpoint.
End point. Like that?
Row.
Row. Awesome. And now instead of start point column plus the length of the side, Ella, what should this be? Instead of start point column plus length of side.
Endpoint column.
Endpoint column. Perfect. So now what we're doing is we're saying I will have a starting point and I have an ending point. I also have a starting point and an ending point for the row and the column. And these are determined by the before blocks. The blocks of code that we wrote, right? Let's run this now. See what happens. Run. Ta-da! We now have our starting point of row 10, column 350. We have our length of the side being 701. Very large. And 701 goes past our length of the side, right? Sorry, our 701 goes past this new column is going to go past it to 1051, which does not exist. So we're saying the end column is now going to be just the width of the image. All the way up there and stop right there. Does that make sense of how we got there? Yes, no, yes, no. Yes? Okay, great. Now, we have a function that does exactly what we want it to do. So now instead of 701, let's make it like, I don't know, 300. Okay? We run that. Works well. Awesome. Let's have a new start point row. Tyler.
200.
200. New start point column. Caesar.
80.
80. New length of side. Ella.
240.
240. Run that. Ta-da! We have our filter. Our red filter. So did we see how we got here? So far? Good? Great. Now what we want to do is the checkered pattern. Okay? Checkered pattern. We have our dog. We have our dog. And now what we want to do is do the same exact thing, right? Let's assume that our filter is going to be right there. But now what we want to do is do a checkered pattern, where within this filter, at this midpoint, and this midpoint, we're going to do something different. Now on the top left, we're going to have this be a red filter. On the bottom right, also a red filter. Then on these other two quadrants, we want a green filter here and a green filter there. We're going to have to update our code to do this now. Okay? So, how can we get these numbers? How can we do that? First thing that we probably want to do is find out these like midpoint columns and these midpoint rows. How do we want to do that?
Two new variables.
Two new variables. Let's do it. What do we want to call them?
Midpoint column and midpoint row.
Midpoint column. Let's do row first, and then midpoint column. Awesome. What is midpoint row going to be equal to?
the endpoint minus the start point divided by
Endpoint row minus, which one?
the start point
Start point row
divided by 2
divided by 2
plus the start point.
plus the start point.
Yeah. And then the endpoint row minus the start point row should be in parentheses.
Oh, this should be in parentheses, like
And
that?
then, like another parentheses from the 2 to the very start. Like
Sorry.
there.
Oh, all the way over here?
Yeah.
Like that?
I think
Okay.
so.
Why are we doing this plus point, start point row?
To get the midpoint, like you.
Okay, actually,
Part gets like the distance of half.
so we have, let's assume this is like the inner filter, right? And this is row 10, right there. And this is gonna be row, oh, I don't know, 711. Row 711. And we're trying to find that midpoint right there. So that midpoint, right now the way that we're calculating it is the endpoint row, 711, minus the start point row, 10, which gives us the length of the side, right? That's going to be 701 divided by 2. What is that? 701 divided by 2. That's 350 and a half. Right? 350 and a half. Plus our start point row, which is 10. So 360.5. That make sense? 360.5. Are we done? Yes.
Wouldn't we need an integer divide?
We need an integer divide. No such thing as the 360th and a half pixel row, right? So all we need to do here is just update that to be integer divide. And then we're good. Sound good? Am I missing anything so far, Adria? Thank you. What should we do now for the midpoint column, Caesar?
The same thing, but with the column variable.
Same thing, except with the column variable. I'm going to copy paste that down there. Instead of row, I'm going to make this column. Instead of row, I'm going to call this column. Instead of row, I'm going to call this column. I'm going to make this column. Okay. So now we have our midpoints. Okay. We have the midpoints here. And here. How can we make this checkered pattern now that we have our midpoints? One thing that we can do, probably, is that we have our filter area. We still want to see, we still want to see the entire filter area, the whole thing. But now we want to use either a red filter or a green filter if something were to happen. If we're in a specific area. So how can we check if we're in that specific area? Well, first what we have to do is find out what that area is. So we have here, it's going to be like 360, right? Around there. Around there. We have some midpoint here, some midpoint here. And we know that everything in here is red, everything here is green, everything here is green, and everything here is red. This is for our entire filter. We now have the checkered pattern with our midpoints. So how do we know if our position is, for example, here? How do I know that it's there? And I want to make that one red. Yes?
Like if your like coordinate is less than the midpoint row and the midpoint column.
If your coordinate is less than the midpoint row and the midpoint column, okay, that makes sense. Because if it's less than the midpoint row, it's going to be somewhere up here. And if it's less than the midpoint column, it has to be somewhere over here. Great. So how do I check for that? If?
Yeah.
Then what do I check?
If row is less than midpoint row,
Midpoint row.
then
And
column is less than midpoint column.
midpoint column. Awesome. Let's do that now. What do we have here? Now that we know that our point is in here, what should we do?
Like get your original color again.
Get our original color.
Pixel.
So original pixel is equal to my image, right? At row and at column. Column. Right?
Yeah.
Then?
You'd say my image row column equals, and then new tuple, and it would be original pixel 0, 0, 0.
Awesome. So now we know that as soon as that we're in here, that means that we have to use the red. Okay? We have to use the red. Let's see what happens now. Let's just run that and see what happens. Boop. So that's the red. But this used to be bigger, right? What happened?
Because the other inputs don't fit or don't meet the if requirements, it just ignores everything inside of it.
Exactly. Since no other point exists within here, then we never go inside the if statement. That means that we never update this other stuff. Okay. We also know that our red filter is going to be at one of two places, right? Either here at that point, or here at this point. So how do I check if my point is now over here? So also use the red filter.
You could add an or to the if statement.
Adding an or. Okay. Or, what should I put here now?
Row is greater than midpoint row.
Midpoint row.
And column is greater than midpoint column.
Column is greater than midpoint column. Just to make this a little bit more readable, I'm also going to put these in parentheses. Do we see what we're doing here now? What we're doing here now is if our row is less than the midpoint row and the column is less than the midpoint column, aka somewhere in this quadrant, then we're going to use the red. Or, so like if all this is false, which we saw before, right? And we saw a lot of different false values and nothing ever happened. Or, now if our row is greater than our midpoint row and our column is greater than our midpoint column, then we go inside there again to also use the red value. So now we're over here in this quadrant. Let's run that. See what happens. Ta-da! We have the start of our checker here and our checker over here. It's hard to see with the red, but here's that red flower, right? The red flower is still there because we keep that red value. Great. Are we done? No. What should we do now?
Another if statement for the green.
Another if statement for the green. In here?
Outside.
Outside. Out here?
Inside the second folder.
inside the second for loop. Okay, if. Now we have to check to see where's our green. Right? So our green is going to be here and here. Yes?
Could you just use an else?
We could use an else. Because now we know we're going to be going through the entire filter area. All of it. Right? We're already checking to see if we're in this quadrant or this quadrant. So if we just say else, that means that we know that we're not in either one of these two quadrants. So we can just say everything else, use the green filter. Because either one of those two ways would have worked perfectly. Okay? Let's use else for now. Else, what should I do now?
The same code as the one above, except we change original pixel 0 to original pixel 1.
My image row column like this.
I'm sorry, in the second.
This one goes here. Very nice. Let's run that and see what happens. Ta-da! We now have our checkered pattern with greens and reds. Fantastic. Does this make sense for you all of how we got to this place? Yes, no, yes, no? Just a couple of points. One thing that we could have done is this original pixel is equal to my image row column. We had that same thing in the if and the else statement. One thing we could have done, this is just a small tweak. Again, same exact thing, just lower amount of lines of code. We could have read that out here, right? Our original pixel will always be our original pixel no matter what we're checking for. Right? So this original pixel is also gone. So it could have been like this. Right? Still works the exact same way. Run that. Great. Then, another thing we could have done is let's do that if statement. This other if statement. This is definitely one way of doing it with just the else. Let's also try to do it with an if. If, how do we know we're in this top right quadrant?
If column is greater than midpoint column
Right?
and row is less than midpoint. Greater than, I'm sorry, greater than midpoint.
Row. So that means column is greater than the midpoint column, so it's over here. And then row is greater than the midpoint row. That's down here. So then what should we change?
Change it back to less than.
Less than. You had it right initially. So we know that so this is going to give us this top right quadrant now. So we can do the same thing that we did before. Do that. Or, where else would we be? In the bottom left quadrant. How do we know we're there?
Row is greater than midpoint row.
Midpoint row.
And column is less than midpoint column.
Column. Let's run that. Same thing. Okay? So two different ways of doing it. Right? I'm going to leave it like this, just so we can see exactly. Would this work if I did this? Yes. This LF would still work, because now all that's happening is that first I'll check this one, and if that one doesn't work, then I'll check this one. The way that we had it before with two ifs, would our system be checking one of these ifs or both of them? Both. If it's two different ifs, it's just going to check both of those things right away. With this elif, we're saying check this first, and if that's good, then don't even think about reading all this other stuff. We don't need to think about it, right? With an elif, now that's what it will do. If it finds this right, great. And if it doesn't, then it checks over here. Rather than having two if statements and checking every single time both of those things, right? So now we have our checkered pattern. Fantastic. What if we wanted to change this to be maybe like a blue filter instead? Oh, actually, Audrey, for lab, do they do inverse color?
Inverting, yeah.
Inverting the color. How do we invert our colors now? How can we invert our colors? Let's make one of the quadrants. Let's change our red filter to be an inverse filter. Right? So instead of doing a red filter and just looking at the red pixel, let's inverse all the values that it had before. How do we do that? Who was in lab yesterday? Raise your hand. Great. So for the inverse, what should we be doing? Okay, so we're going to update our red filter. Where's our red filter right now? The first or the if or the elif?
If.
The if statement, right? Let's invert our colors now. How do we do that?
250. It was 255 minus the original value.
255 minus the original value. So we do 255 minus that original pixel value. Am I done?
Where is it?
Tyler, you shook your head. Why am I not done?
I think you have to repeat it for green and blue.
Yes, we have to do it for all three of our values. If we left it like this, we're only inverting our red value and then leaving the rest as zeros. If we want to invert the entire image, right, of all the colors, then we have to do the same 255 minus for all the things. So 255 minus the original pixel at position 1, and then 255 minus the original pixel at position 2. Okay? So now what we should be seeing is instead of red, green, green, red, we should be seeing inverse, green, green, inverse. Yes, question?
If the original value, wait.
No, go ahead.
No, I was gonna say if there would be any way, or it would be less than 0, but I don't think it's.
Oh no, yeah, we'll never get to less than 0 because the original pixel value will always be between 0 and 255, right? So that means at one extreme, if it's at 0, we do 255 minus 0, the result is 255. Or the other extreme, where original pixel value of the like R, G, or B, the max value that it should be having so far is 255. We can assume that. So at that other extreme, 255 minus 255, it'll be 0. Okay. So now let's see that inverse. Initially looked like this: red, green, green, red. Let's look at it now. Oh! This is the inverse, right? The inverse of red is blue, I guess, right? The inverse of this blue is red. And we still have our green filter, as is. That's pretty neat. So now we have our checkered pattern. Is this going to work for any position that we give it? Yes. Give me some position. Any position.
50.
50. Caesar, give me another position.
700.
700. Ella, give me the length of the checkered pattern.
400.
400. Let's run that. Ta-da! Where is it? It's right there. Very small. Right? But we have our greens. Can you even see that? You can like barely see it. That's like a little sliver of green right there and a little sliver of black, because the inverse of white will be black. And then that little sliver of black and that little sliver of green. Hard to see, but we did it. Okay? Now our checker pattern will always, always work. Fantastic job. Y'all did a great thing. Okay? And that's all within a function. Any questions so far about what we've done and how we got to where we got? That's nice. No? All right. So, 8x8 grid, life outer region. Oh, I'm going over these things just because we've already done a lot of this, right? And row and column. Well, this is like blacking it all out. We did our checkered pattern. Great. So, what will be the contents of checker.txt? Oh, wait. We haven't done create image yet. Let's create an image. The create image function that we have here will literally make you, let me save all this other stuff. Or actually, I could leave it all as is. Okay. Let me get a new thing over here. The create image, my created image, create image, it asks for three things: a height, a width, and a color. Okay. Let's do, how high do we want this image to be, Caesar? How many pixels? 800 pixels? Whoops. Nice. Ella, how wide do we want this image to be? How many pixels?
700.
700 pixels. Nice. What color do we want this to be? Tyler.
25500.
25500. What color is that?
Red.
Red. So now, if we save image to my created image, and we put, I don't know, my created image.jpg, run that. We have the thing that we created, right? And then we also have my created image. 800 pixels tall, 700 pixels wide, and it's totally red. Okay, that's what it'll give us. So now, what about this? What will the following system give you? I'll give you all just a couple of minutes to look that over and see what will happen with this exercise. What is the answer to this question? A, B, C, or D?
D.
D. Why is that?
Because create image, or the image is a 2 by 2 pixels,
Yeah?
and it's a white.
Just a white square,
Yeah,
right?
white square.
By 2 by 2. Then we go to checker.
And inside checker, in the second if statement, we only apply it if r is less than half the height, which is 1, so it's only applied to the first row.
So it's only going to look at if the row R is less than the height divided by 2. So it's going to look at the top half, right? It's going to make it 25500. Otherwise, it's just making 00255. So it's basically what it's doing is that anything at the top half will be 25500, and anything at the bottom half will be 00255. which is D. Okay? Oh, where did this? Yeah, thinking big. Okay. Loading our image, our checker pattern, and all conditions. Oh, we already handled the edge cases too? Well, oh, dang. Hello, hello. Dang it. It's the first time that happens to me in this whole course. Alrighty. Here. Can you all see? No. Too much knowledge. Any questions so far on what we've done? No? No questions at all? So we've done the edge case of it going out of bounds. Great job with that. I guess we can get into dictionaries. Yeah, we have 10 minutes left. Dang it. This is censorship. Can't believe this. Check this other one. All right. What the heck? We're so close. Okay, you know what? If this doesn't work, I'm gonna do it good old-fashioned chalk and chalkboard. Nope, not working. Okay, that's fine. Whatever. I didn't want to use my computer anyways. Let's do the following. Tools. Protect your screen. Oh, very nice. All right. So, we have covered everything there is to cover basically with images so far. We know how to use, we know how to read in an image. How do we read in the image? What function did we give you? It's called load image. We give it to you. Where's load image located? Where is that function created?
The file we're not supposed to touch.
The file we're not supposed to touch. CSE 8A image. Should we edit CSE 8A image? Ella, should we edit that file? No! Never edit that file. Okay? Because we wrote that for you. You don't have to worry about what it does. All you have to know is that it works. Load image will load your image. Okay? And then once we loaded an image, we saw how we can go and edit pixels, right? Or we saw how we can go through an image, row by column, with our nested for loops, right? We saw how we can edit each individual pixel, and we can define what those pixels will be. With like, it could be like a totally solid color. We can use some of those original values of the pixel and keep that kind of stuff and do other things with it, right? We can do all that kind of stuff. And now we also do it with a function, right? Where now with our function we say we have a start point for the row, we have a start point for the column, and we want a certain length, right? And then we can make that filter. We can also check to see if we're going out of bounds, right? If we're going out of bounds and we don't like that, we don't want to do that. And we do that by checking to see if the start point of the row plus the length is greater than the height of the image, right? Same thing for the column versus the width of the image. So now we can do that. And then we can also do some checker patterns, right? Within our filter, we can do different things. All of that for images, great. Okay? I am now going to introduce you to a new concept outside of images. So I want you to learn everything you learned about images, keep that in your brain. We're going to move on. Okay? We're going to move on to something called dictionaries. All right? Dictionaries. Dictionaries are a new data type. Dictionary. Okay? This is a data type. What other data types have we learned in this class?
Lists.
We have learned of lists. What else?
Ints.
Ints. What else? Floats. What else?
Strings.
Strings.
Bools.
Bools. Anything else?
Tuples.
Tuples. Awesome. Anything else? I don't think so, right? I think that about covers it. All these data types we've used so far. A new player has entered the ring. Dictionaries. Okay? Dictionaries are going to be acting similar to a list. Okay? Similar to a list with one key difference. Okay? A dictionary is kind of, actually, have y'all heard of what a dictionary is? Like any dictionary? At all, like outside of computer science. What is a dictionary? What is a dictionary? Noah.
Where you look up meanings of words.
You look up the meanings of words, right? You look up the meaning of the word. Let's say you want to look up for the meaning of the word book. How do you find the definition of book in a dictionary? Not a trick question.
You go to the table of contents and look for where B is? Or-
You look for B, right? You go all the way to where B is. Like as soon as I open up for B, there's book? No, you have to go look for it, right? You have to look for it, check to see where book is, and once you see where book is, then you can see its definition, right? What number word is book in the whole dictionary? I don't know. Do you know? I have no clue. Do you know that? I don't know either. Caesar, you gotta help us out. Do you know what it is? No! Okay? But that's okay. Okay? Because what we know what to do is it doesn't matter what number it is, right? We don't care about the number of where it is in the dictionary. We just want to know that the word book exists within that dictionary, right? Dictionaries in computer science are quite similar. Instead of a list, I said it's going to be similar to a list, right? Similar. Lists use these brackets. Tuples use these, right? These two are also kind of similar, right? Lists and tuples, except tuples are immutable. Dictionaries use these curly brackets, okay? Curly brackets. And what we're going to use with dictionaries now is instead of a list, which goes like this, 0, 3, 5, right? There's a list with 3 integers, 0, 3, and 5. What dictionary is going to do is that you can have something like this, a string, book, you're going to have a colon, and then you can have whatever you want over here. Just put a definition. What's the definition of a book? Actually, I have no clue what the definition of a book is. Now, can you look up the definition of book? I feel like I put myself in the corner here, right? I don't know what the definition of a book is.
Or written or printed work consisting of pages glued.
Okay. A written or printed work.
Consisting of pages glued or sewn together.
With pages, I'm just gonna put pages. I'm so sorry. it's a whole lot of stuff, right? This is a valid dictionary, okay? Let's name this dictionary. Let's give it a name. What name do we want to give it? Let's give it any name that we want to give it. Ella, can you give me a variable name? Any name at all.
Class.
Class. Love it. Okay. We have a variable called class, and we're setting that into this dictionary. Right? Book goes to a written or printed work with pages. What we can do now is we can access our dictionary, similar to like a list, class, open bracket, but now this will not work. This will not work, okay? Because there is no key, oh sorry, I should give you the definitions for these. Book now, this is what is called a key. This definition right here is called a value. Okay? So for dictionaries, a dictionary key will be something like this, book. And the dictionary value will be something like this. It could be a string, it could be an integer, It could be a float, whatever you'd like for it to be. Okay? But that is a value. But there are no keys called 0. So like with list, this list over here, what's list at position 1 for here? What will we get? 3. Right? Because the index says this is 0, this is 1, this is 2. Right? For a dictionary, it does not use indices at all. This will only look at keys. Keys only. So the way that I could do this is that instead of class at position 0, I could say, I want to look at the class at position book. Class at position book. Okay? And this will return all of that, this whole value. A written or printed work with pages. Okay? This will give me this whole string. Okay? Any questions on dictionary so far? This is how a dictionary works. Therefore, what if I wanted to add another key value pair, although that's what these are called. Since that's a key and that's a value, dictionaries ask for key value pairs. You need a pair. You can't have a key and no value. And you can't have a value without a key. The way that you can add more is you just, like we've done with these, right? You just need a comma, and you have a new definition. What do we want to define now? Give me an easy definition. I don't know. Chair. 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 So what you do is you have your key, you have a colon, and then